All right, this lesson is on simplifying radicals review part 2. If you haven't seen part 1, go ahead and go back and see that. This lesson is best copied in your paper notebook, and it's part of the Unit 6 square root functions unit. So today we're going to continue simplifying radicals in exponential form and simplified radical form, but it's going to be a little bit more advanced in part 1. Okay, so let's go ahead and take a look at simplifying radicals in binomials. So whenever they're inside binomials, yes, we're going to go ahead and multiply it like we would. As far as you think about it as an exponent, I'm sorry, not as an exponent, but as a variable, but it's also a radical. So there are different properties that do exist with radicals, and we'll talk about those. Now, remember, when anything is squared, we can always rewrite that because there's 2 of them. So we would have 4 plus 3 square root 6, and we'd also have 4 plus 3 square root 6 because there are 2 of them. All right, now that we have 2 binomials, what we're going to do is we're going to go ahead and FOIL that out. So it's going to be first, outer, inner, last. 4 times 4 is going to give us 16. 4 times 3 square root 6 is going to give us 12 square root 6. And then inner is 12 square root 6. And then this is going to be a little different. Okay, so when we write that out, I want you to think about it like we need to multiply the coefficients first. So 3 times 3 is going to give us 9, but the square root of 6 times the square root of 6 is just the square root of 36, which I'll write out here, but in the future we're just going to say this is 6. So our next step is to go ahead and combine like terms. So 12 square root 6 is going to give us 24 square root 6, because these are like terms. And then we're going to end up with 9 times 6, which gives us 54. Hey, we've got another common term. So 54 plus 16 is just going to give us 70 plus 24 square root 6. All right, that's as far as you need to go. There's nothing else that we can simplify inside the radical. It's completely simplified, so you're done. All right, let's go ahead and take a look at number 2, our second example. Okay, notice how these are not the same, but we're still going to go ahead and go through the process the same way. So we're going to have first, outer, inner, last. So the square root of 2 times the square root of 3 is going to give us the square root of 6 plus the square root of 2 times negative square root 6 isn't going to be plus anymore. That's going to end up being minus. Okay, so we're going to have subtract the square root of 12. Inside, negative square root of 15. And then plus 30. Whoop, not 36, but 30. All right, now looking at this, we could take a look to see if there's anything that we can simplify radical. So simplify radical form. So let's take a look at 6. 2 times 3. Is there a group of 2 numbers that are the same? Nope. So the square root of 6 comes down. You want to take a look at every single number. Okay, so this is 12. Wait a minute, there's a perfect square. If you take the square root of 4, that would just be 2 square root of 3. 5, or 15 would be 3 and 5. That wouldn't simplify. And the square root of 30 is 5 times 3. I'm sorry, not 3. I was getting ahead of myself. It's going to be 5 times 6. 2 times 3. We do not have a group of 2 numbers that are the same, so we would just bring down the square root of 30, and this would be your end answer. There's nothing you can simplify about that, because remember we talked about these being kind of like variables of their own. The radicands have to be the same in order to combine them. Okay, so this is like saying x plus y plus z plus r. We can't combine those, so we would leave them the way they are. Okay, when you multiply, yes, you can multiply those. All right, let's take a look at example 3. So with example 3, we have those 2 binomials. We're going to go ahead and FOIL this out. Okay, so we're going to have 7 times 7, which is 49, minus 7 square root 2 plus 7 square root 2, and then minus the square root of 4, which is just going to give us 2. Remember, that's square root of 4. Hey, I noticed something I I forgot to mention. Okay, these two binomials are the same except for their middle signs. Notice how we have a difference of squares going on. You remember with the difference of squares, we're going to end up with our center terms canceling out. So we would be left with 49 minus 2, and 49 minus 2 is just going to give us 47. All right, that's actually called a conjugate, and we're going to talk about that a little bit more because we want the middle term to cancel out. Notice how we were able to get rid of the radicals altogether for that problem, and that's going to help us out in this next step when we need to rationalize the denominator with conjugates. Because notice how we have a radical in the denominator, but it's not alone. Whenever something is in the denominator or the numerator for that factor, that matter, they're together and you have to write them with parentheses. Alright, so let's go ahead and go over these notes. So 7 plus the square root of 2 and 7 minus the square root of 2 are conjugates of each other. Each have the opposite signs between the numbers and the roots. What do you think happens when you multiply two conjugates? Well, kind of talked about it, but those center terms cancel out and we're left with no more radicals, which is awesome because these radicals squared each other and simplified out. So over here, in order to get a radical out of the denominator, we're just simply going to multiply it by its conjugate. And remember from last unit, our last lesson, when we were talking about trying to get the radical out of the denominator, we have to multiply it by 1. So whatever we're dividing it by, is in the numerator, because if I were to simplify this entire thing down, this would just become 1. But we want to use it. It's going to help us change this equation and get that radical out of the denominator. So in the numerator, we're going to multiply 2 times 5, which is just going to give us 10 times 2 square root 3. And in the denominator, we have 5 times 5, which is 25. And I'm only going to do this first time, but I want you to notice, well, maybe not the first time. I want you to notice what happens. This becomes minus 5 times the square root of 3 plus 5 square root of 3 minus 3, because we have the square root of 9. So the center terms cancel out. The numerator, there's nothing to simplify. Divided by 25 minus 3. So 25 minus 3 is going to give us 22. Okay, you want to look at the coefficients, or constant as well, and see if it can be divisible by anything. Now I notice this entire fraction can be divisible by 2. The radicand is not affected by dividing out real numbers. Alright, so looking at this, 10 divided by 2 is going to give us 5, minus 2 divided by 2 is 1, all divided by 11. And that's our end answer. Alright, there's nothing else that we can do there. Let's take a look at, let's take a look at our last example for today. For our last example, we do have square root of 5 minus 1. I'd like you to pause the video and see if you can do this one by yourself. It's very similar to 4. And we're going to go ahead, I hope you went ahead and did the problem, otherwise, no, seriously, pause. We're going to go ahead and get started. Okay, so I'm going to multiply by the conjugate, so that's going to be the square root of 5 plus 1. Whatever I multiply from the denominator, I must multiply the numerator to keep it balanced. And then the numerator is just going to end up being the square root of 5 plus 1, because anything times 1 is itself, all divided by, okay, now I have a binomial times another binomial, so it's going to be first, outer, inner, last. So that's going to end up being the square root of 25. I'll write that out, which would just be 5. Plus the square root of 5 minus the square root of 5 inner, and last would be minus 1. Okay, so there's the square root of 5 plus 1 in the numerator. Nothing simplifies there. We have 5. These cancel out because we are multiplying by the conjugate. 5 minus 1, which is just to give us 4. There we go. That's our end answer. Now remember, if you have any questions about the content that you watched today, or you don't understand homework, please go to Miss Young's tutoring, or anyone else who's available for tutoring. Okay? Have a wonderful day.